All right, everybody, welcome back. Today, what we're going to do is we are going to further our understanding of the unit circle. All right, so I started with a blank unit circle here. And as a reminder, what this really is a zoomed in coordinate plane. We are just looking at our origin and then one unit to the left, one unit to the left, one unit to the right, up, down, and so on and so forth. All right, so our unit circle is 360 degrees or 2 pi radians. All right, so an angle that opens and then closes in the same spot and goes all the way around is going to be 2 pi radians. And so that gives us some information on some other values, some other angle measurements. Half of that would be an angle that opens in a straight line, and that is going to be 180 degrees or pi radians. And then half of that is going to be 90 degrees or pi over 2. All right, finally, we've got our angle measurement that is essentially, actually, equal to 270 degrees, and that is going to be 3 pi over 2 radians. All right, now we also know some coordinate values. The coordinates of these values are going to be 1, 0, because all we are doing is starting at our origin, moving to the right. This one is going to be 0, 1 up top. And then to the left will be -1, 0. And then down low will be 0, -1. Well, we really need to dive into those trig functions. So what we're going to do today is we are going to figure out how to find some other values on our unit circle. Okay, so specifically what I want to do is take a look at some special values. So for example, we all should be pretty familiar with 45, 45, and 90 triangles. Well, 45 degrees is actually right here. All right, and technically, since this is pi over 2 radians, this is half of that, or pi over 4 radians. So this is going to be an important value for us. And the reason that is because we know some rules about 45, 45, 90 triangles. Now, these rules, if we don't remember, follow the idea that across from our 45-degree angles, we have a side length of x. And actually, this one's 45 as well, so that makes this side also have a length of x. Our hypotenuse is going to be x times √2. Those are the rules of a 45, 45, 90 triangle. Well, using that information, we can actually figure out what the values would be in our unit circle. We could find how far to the right we're going, which is our x value, and then how high we go, which is going to be our y value. All right, and it all comes off the idea that our unit circle has a radius of 1, So our hypotenuse right here coincides with this value, and this is a radius. The radius of the unit circle is 1, so that means that x √2 should be equal to 1. Now, all we have to do is get x by itself, which we did right here by dividing by √2. The problem is we want to rationalize our denominator, so I'm going to multiply by √2 over 2, and we are left with √2 over 2. So that tells us that both the horizontal distance and the vertical distance of this triangle in the unit circle, which is this one right here, is √2 over 2. So the coordinates of this point right here are √2 over 2, comma √2 over 2. So not only do we know the coordinates for the angles in between our quadrants, the quadrantal angles, but we also know some more information. We know that we have right in the middle pi over 4 radians, and the coordinates of that point are going to be √2 over 2, comma √2 over 2. All right, so using that idea, we can actually fill in other values around our unit circle. And we do that by reflecting. If I take this side and reflect onto the other, I went a little bit too far there, but we are going to get another value right there. Well, when we reflect points from quadrant 1 into quadrant 2, the values are going to be exactly the same, except now in quadrant 2, the x values are negative. So that point has the same coordinates as it did over here. However, our x value is going to be negative. So if this is 1/4, then the value up top right here should be 2/4, which is 1/2. This one will be 3/4. So this should be 3 pi over 4. So that tells us that the angle measurement right here is 3 pi over 4 radians. Now, if that's 3 pi over 4, then 4 pi brings us all the way across. We have 5 pi over 4, which would be this angle right here. And so I'm going to put a point down there. We have 5 pi over 4. And then 6 pi over 4 would be here. Let me divide this up like we did before. So you got 4, 5, 6. That means 7 will be this angle right here. And then bring us all the way around will be 8 pi over 4, which is 2 pi. So we actually have another angle right there, which is 7 pi over 4. All right, all these coordinates are going to be the same values. However, we just need to determine what is going to be positive and negative. Now, if we reflect over our x-axis, we got to remember that these points are going to be the same. Except now, because we are in quadrant 3, both x and y will be negative. So that's going to be 5 pi over 4 is the radian measurement. So let me show you that real quick. That is this one. And the coordinates of that value on our unit circle is going to be negative root 2 over 2, comma negative root 2 over 2. And then finally, we've got this angle measurement, which is 7 pi over 4 radians. And again, it's going to have the exact same coordinates. Except now in quadrant 4, only our y value is negative. So we're using that first quadrant here to find a bunch of other values all throughout our unit circle. And we're going to continue with that idea. Now, if we take a look and we use a 30-degree triangle, that's going to give us a triangle that looks like this. All right, and the reason we want to do that is because we also have rules for 30, 60, 90 triangles. Now, 30, 60, 90 triangles follow the idea that our hypotenuse has a length of 2x. Our side across from our 60 is going to be x root 3. And then our side across from our 30 is just going to be x. So using the same idea as before, we got that triangle right there. We know that since our hypotenuse is equal to 1 on the unit circle, that we can find the lengths of both our horizontal value and our vertical value that will get us to another point on our unit circle. We get x equals 1/2. So the vertical distance there is 1/2, and our horizontal is going to be 1/2 times root 3, which is root 3 over 2. All right, and just a reminder, 30 degrees is equal to pi over 6 radians. So if we use that same logic, and I'm just going to add it to our circle up here, what color do we want to do? Let's do blue. All right, pi over 6 is going to be roughly right there. And again, that is this angle measurement. That's pi over 6. And it has the coordinates root 3 over 2, comma 1/2. So the exact same idea is what we're going to use to find some other values. If I reflect it over our y-axis, we are going to end roughly right about there. Well, if we think about this, this is 1/6 times pi. Well, this angle measurement should be 1/6 less than pi, which means 5 pi over 6. Some people like to do it like this. I'll show you. We've got our pi, and then there's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. So using that, we can fill in some more values. Again, the coordinates are going to be exactly the same, except now we are in quadrant 2, so our x is negative. And now when we reflect down, we get another point right here, and those coordinates are both going to be negative because we are in quadrant 3. And now let's think about this. This is going to be pi radians. This is an extra sixth, so we're going to be working with 7 pi over 6 radians. And again, we're going to reflect over our y-axis to end up right about there. And that is going to be almost a full circle with 1/6 left over. And so let me just draw this out so we could see it all. We've got pi, we've got 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6. This will be 11 pi over 6 radians. And again, same coordinates, except we are now in quadrant 4, so only our y value will be negative. So we're starting to fill in this circle a bit. We've actually got one more that we're going to take a look at, and that is going to be a 60-degree triangle. So that's going to be something like this here, where that angle right there is 60 degrees, and 60 degrees is equal to pi over 3 radians. If we want to do the conversion, we could, but we're going to hold off for there. Well, if you notice, this is the same triangle over here, except our vertical and horizontal values are going to be the opposite. All right, it is the same rule that we used previously, except across from our 30 should be our x, across from our 60 will be x root 3, and then 2x as our hypotenuse. All right, so I could show you again real quick. Our hypotenuse is actually equal to 1 in the unit circle, so that means if we solve, we get 1/2 is equal to x, and that is going to be our horizontal distance. So that means the coordinates of this point is going to be 1/2 comma root 3 over 2. And that's an ugly root 3 over 2, but we're only using it for this example here. And I can jump back up to the top. And why don't we do this one in pink? So pi over 3 radians is roughly right there, and that's what this angle measurement is going to be. And the coordinates on our unit circle are going to be the same as the one before, except now our x and our y values are going to be switched. All right, so we've got, let's see, this is pi. This is pi over 3. This should be 2 pi over 3. So we got another one right there. That is going to be 2 pi over 3 radians. And again, we're talking about this angle right here, this one on the inside. So if we reflect over our y-axis, we're now in quadrant 2. The coordinates will be the same, except our x value should be negative. All right, so we've now got 1 pi over 3, 2 pi over 3, and 3 pi over 3 completes the top half. Then we have 4 pi over 3, 5 pi over 3. So we've got 4 pi over 3, 5 pi over 3. And that should make sense because this angle is about 1/3 of a half of the circle to getting us all the way back around, which would be 6 pi over 3 or 2 pi. So let's fill in our coordinates again. These need to be the exact same, 1/2 comma root 3 over 2. And we're now in quadrant 3, so both values will be negative. And now 1/2 comma root 3 over 2. And now in this case, only our y value should be negative. So using some simple math, using what we already know about right triangles, and using the 30, 60, 90, 45, 45, 90 rules, we can come up with some other angle measurements and their values on our unit circle. Now, we got one more thing we got to talk about here, all right? And that is introducing our trig values. So we have sine cosine, and tangent. Many of us from our geometry course remember that sine is going to be the opposite over hypotenuse. Cosine is going to be the adjacent over our hypotenuse. And then tangent is going to be our opposite over adjacent. All right, what we need to remember is we can start to take sine values or cosine values of specific angle measurements. So in this case, I'm going to do sine of, why don't we just do pi over 4 because that's what we started with. All right, so that means we need to find the sine value of this angle right here. Well, if I just sketch that triangle out real quick, all right, we've got our angle measurement of pi over 4 right here. And then we have our root 2 over 2 there. All right, so these are our side lengths. I even got the 1 for our hypotenuse. Sine is equivalent to the opposite side, the opposite divided by our hypotenuse. So really what that is it's our vertical value divided by 1, which is essentially just the vertical value. So when you are taking the sine of an angle, all we are looking for is the coordinates on the unit circle, and we are looking at specifically their y value. So for example, if we had to do sine of 3 pi over 4, all we need to do is take the y value of that measurement on our unit circle. So sine of pi over 4 is equal to root 2 over 2. And using that same idea, sine of 3 pi over 4 is equal to, let's do something else so we don't have the same values. Sine of, why don't we do 2 pi over 3? Again, sine is that vertical value. It is opposite over hypotenuse. So that means we have, what is it, 2 pi over 3? I've got this angle measurement right here. Technically what we're doing is we're finding the sine value of this triangle. All right, and in that case, it is root 3 over 2. So sine of 2 pi over 3 is going to be root 3 over 2. So whenever you're taking the sine of a radian measurement, especially one that we have on our unit circle, all we're looking for is the y value of that point on that unit circle. All right, cosine is going to work similarly. If we have our triangle right here, let's do pi over 6 this time. So pi over 6 has coordinates root 3 over 2 and 1/2. And then 1 there. So this is just the triangle from right here. All right, cosine is our adjacent side from the angle over our hypotenuse. So that would be root 3 over 2 divided by 1. So that's really just anytime we say the cosine of an angle measurement, we are looking at the x value of the coordinate on our unit circle. So cosine of pi over 6 is just the x value of that coordinate on our unit circle. This is the one we're talking about, which is root 3 over 2. All right, and now we can continue to do this. We could even do things like cosine of pi over 2. Well, cosine means we're looking for the x value. That is this one right here. That's the angle we're looking at. Well, the x value of that is just 0. So cosine of pi over 2 is 0. All right. So lastly, we can also talk about our tangent, and tangent is going to work the same way. It's just going to work out a little bit better for some angles than others. If we go back to our pi over 4, we know we have root 2 over 2, comma root 2 over 2 with a hypotenuse of 1. So again, we're just looking at this angle measurement here, and technically that triangle. Now, tangent is opposite, which is this divided by this. So tangent of pi over 4 is going to be equal to root 2 over 2 divided by root 2 over 2, which is just 1. Okay, so whenever we're finding the tangent of an angle measurement, all you have to do is take the y value and divide it by our x. So let me give you another example. If we do tangent of, Let's just do 11 pi over 6. It's the first one that came to my mind. So we are going to go to our unit circle, find 11 pi over 6, and take the y value and divide by the x value. So this one's a little bit more complicated, which is why I chose to do it. We have negative 1/2 divided by root 3 over 2. So it's going to take a little bit more work for us, but we have negative 1/2 times 2 over root 3. Instead of dividing by a fraction, you can multiply by the reciprocal. We end up getting negative 2 over 2 root 3. Well, the 2's should cancel, so I am left with negative 1 over root 3. Well, we don't really like to have radicals in our denominator, so I'm going to do a little more work up here. If I rationalize, we should end up with negative root 3 over 3. So it's a little bit more of a drawn out process because tangent is a little bit more complicated. But all we're doing is when we ask someone to find the tangent of an angle measurement, you have to take the y value of its coordinate on the unit circle and divide by its x value. Okay? So we're still using these ideas of our definitions for sine, cosine, and tangent. We're just kind of figuring out how we can actually take the sine, cosine, and tangent with specific inputs using our unit circle. Okay? So this is our unit circle, which we found using our 30, 60, 90, 45, 45, 90 triangles and using some reflections to get their coordinates. And then hopefully we realize that, hey, if you're asked to find exact values like the sine of a specific angle measurement, it's just asking for the y value of its coordinate. Cosine is therefore just asking for the x value of its coordinate. And then tangent is just asking for the y value divided by its x value. Okay, so unit circle is a little bit more complicated. I get that. I do understand. But again, we're just trying to introduce some of the ideas that come with things, our functions, our trig functions, sine, cosine, and tangent. And the unit circle is our tool to do that, okay? If you have any questions or concerns, as always, please feel free to leave a comment below, and thank you for joining.